Got it right next to me here. Test is tomorrow. You do get a calculator. Won't help you on most of them. In fact, at the top it says a calculator is required for some of these problems. So you'll have it when you need it, but you don't need it. I would say you don't need it often. Let's see. SOHCAHTOA. I'm just going to breeze through the test and write down the things I would need to know if I was going to work this test. A squared plus B squared equals C squared. Using the calculator for cotangent of 58 degrees, as well as the ones that are a little bit harder, if secant of theta equals 2.7, find theta. You okay with the difference between those two and how you would handle those differently in the calculator?
Could you do the top one? I have to do the bottom one.
So first thing we should do is make sure we're in degrees, especially if you're borrowing my calculator, because right now pre-cal's in degrees, calculus is in radians. So if you're using one of mine, that's fine, but it'll depend on who had it last as to what mode you're in. So cotangent of 58, how do I do that? Not negative tangent. 1 divided by tangent of 58. Whatever that is. 1 divided by tan 58. 0.625. How about secant equals 2.7? I don't have a secant button either.
Oh man, gee, I wonder if that one.
So who is secant related to? Who's his reciprocal partner? So that means cosine equals 1 over 2.7. So anytime we're looking for an angle, we're going to do the inverse button. Anytime you're looking for an angle, you'll do inverse cosine. Or inverse, whichever one you're looking for. Second cosine, 1 over 2.7. 68.262 degrees. Hopefully on a multiple choice test, if you make the mistake, it won't be there and you can go figure out what happened. Let's see, there's a squared plus b squared equals c squared, and SOHCAHTOA. Ladder leans against the wall. Radians to degrees, degrees to radians. And the main thing there is that pi radians equals how many degrees? 180. That's the conversion factor. Coterminal, how do you find coterminal? Plus or minus 360, however many times you would like to go. Remember, that's the one where if it was free response, and thankfully it is not, but if it was free response, that's where you could add 360 473 times and make me figure out if it what you've done. We don't give you that option, thankfully.
Leave the answer as a blank.
You could also add or subtract 2 pi. That would be if you're in radians. So arc length. L equals. Here's how I remember this formula. What's the all the way around arc length called? What's the name of that if you go all the way around? Circumference. And what's the formula for circumference? 2 pi r. Because the 2 pi meant we went all the way around. So if we don't want to go all the way around, we still have r. Pi r would be halfway around. If we didn't know how far we were going around, we put theta. And so if theta is 2 pi, that's all the way around. If theta is pi, it's halfway around. If theta is pi over 3 or pi over 6 or whatever, theta times r. Theta has to be in radians, though. Don't put it in degrees. Sector area. Again, I start with the full area because I know that formula. And you know that formula. Right? Area of a circle? Not base times height. Pi r squared. So the area of a sector, I start with pi r squared, and then I multiply by theta over 360 or theta over 2 pi, depending on which angle I'm in. And so that gives me a fraction of the circle. Right? If I went all the way around, I'd be multiplying by 2 pi over 2 pi. That'd be all of the circle. So I like to tie arc length and sector area to the formulas that I already know. That helps me remember those two specific formulas.
Are we going to need to know, like, for it's like complete the unit circle and angle, like, why do we need to, like, is there going to be that one?
We'll get there.
Okay.
SOHCAHTOA at a point. So that's remembering that opposite goes with y, hypotenuse is r, adjacent goes with x, or maybe just xy goes to a and o. So if you want to use SOHCAHTOA, that's fine, but you got to know who's opposite and who's adjacent. They're alphabetical. I think I mentioned that. X comes before y, a comes before o. So rather than memorize the x and y and r set of SOHCAHTOA, basically, you just remember that x tells you adjacent, y tells you opposite, and then you're back to using SOHCAHTOA. Quadrants and angles. You know, like what quadrant is 3 pi over 4 in, that sort of thing. 3 pi over 4 is in quadrant. And this is where it would probably be helpful to 3 pi over 4? 3 pi over 4 is in quadrant. Let's see, that's 0. Like, I would strongly suggest there's a picture on the, I'll just show you the question. I'm not giving anything away here. Complete the unit circle angle measures in radians with just a blank unit circle. This is actually the test I'm showing you right now. So I would jump to 23 and work this problem. Then you could answer a bunch of these questions. And remember how we did this? You don't memorize all of those.
Literally just 25.
What's all the way around in radians? 2 pi. And then you kind of start backing up from there. Halfway around would be pi. Half of that's pi over 2. 3 pi over 2. We can stop there for this question. 3 pi over 4, what quadrant's that in now? Where's 3 pi over 4?
Yeah, those two questions I
Bigger than pi over 2, not as big as pi. So quadrant 2. Reference angles. Oops, if I could spell. Puzzle problems. Do you know what I mean when I say puzzle problems? If, let's see, cosine is equal to negative 5/13 and tangent is greater than 0, find the cosecant of theta. Let's do that one. This turned into warm-ups / test outline, but that's okay. Hope I didn't make that one too similar to the test question. So job 1 is to draw the picture, correct? And part of that might be thinking about all students take calculus. Let's see. Cosine is negative on the left. Tangent is positive. Where's tangent positive? 3 and 1. So this one's got to be in quadrant 3. If cosine's negative and tangent's positive. So it's got to be in quadrant 3. Cosine. What's cosine in terms of SOHCAHTOA?
It's in 1. So it's going to be down.
Adjacent over hypotenuse. Hypotenuse is the easy one. Adjacent, is that the x piece or the y piece? Because it's always, adjacent is always the x, or adjacent's always closest to the angle. So that adjacent is negative 5. I have a missing side now.
So it's negative something.
That's a great point. It's negative something. I don't know what it is yet, but it better be negative because it's going down.
So it's not greater than 0. Oh wait, no, that's just.
Well, that side length is going to be negative. Do you know how long that side is going to be?
A squared plus b squared.
You can use a squared plus b squared equals c squared.
Plus b squared.
Or you can remember,
Oh, not those things.
I mean, you got a calculator, so if you need it, that's fine. It's a 5, 12, 13. So am I done with this problem yet? No, because I was asked what's the cosecant. Cosecant. I don't think in terms of cosecant. Who's cosecant partnered with?
Sine.
So I need the flip of sine. Sine is opposite over hypotenuse. So we need hypotenuse over opposite. So it's 13 over negative 12. And it would probably be written as negative 13 twelfths. That's what I mean by puzzle problems.
What's 3, 4, 5? What's that?
Those are the special right triangles or Pythagorean triples. If you remember them, they help. They're integers that fit a squared plus b squared equals c squared. If you remember them, they make some test questions go quicker. They're also frequently used on SAT and PSAT. Save you time if you recognize them. If you don't recognize them, it's fine. You do a squared plus b squared equals c squared, but that's costing you time.
So 3, 4, 5, 5, 12, 13, and 8, 15, 17 are all a squared plus b squared equals
Right.
c squared.
And there's a ton more, but we usually don't worry about any past that. They start getting more complicated.
They give you just
I think that's it, other than the one I showed you. Complete a unit circle. In degrees and radians. That was the picture I showed you. In fact, I'll show you both of them. So there's problem 22 and 23 on the test.
How many questions are there?
Giving it to you. There's 24 questions.
Ah, okay. What's 24?
Find the 6 trig ratios given the triangle on the right. That's problem 24.
Okay.
You asked. Sort of gave it to you.
You gave us a question, you didn't give us the numbers.
Yeah, you want question 24? There it is. Find the 6 trig ratios for the triangle that's hidden beneath my hand.
It's just, I mean, that's the same thing as number 27 here, just with a different triangle.
Yeah, that's exactly right.
Can you show us like the first few pages? Is this the review?
This is
No,
the
that's
test.
a
No, no.
He's showing us.
I'm showing you the test.
It's similar.
Sort of. It's very similar to the review, yes.
Different numbers, just
The
same
last three questions are basically the same.
Probably a whole lot more than that are basically the same.
Yeah.